अच्छा, so ये this one peptide formation is also an example of condensation polymers. ठीक है, but so amino acids joining up, ठीक है, लेकिन typical condensation polymerizations there are two types of uh, three types. O levels में you did three types. So condensation, polymerization, so the reason it's called condensation polymerization is what happens in this is you have the first type, ठीक है, that's a polyester.
सर
हाँ जी,
सर ये अलग से या जो वो फ्राइडे वाला है?
वही है, फ्राइडे वाली है.
ओके सर.
अच्छा, वो this is polyester. Polyester is it's got two monomers. One of them is a dicarboxylic acid, ठीक है, तो उसके ना दोनों साइड्स पे there are carboxylic acid functional groups. ठीक है, so there is C double bond O and OH. And on the other side, you have वहां पे भी it's a dicarboxylic acid, and it's going to have OH on that side as well. अच्छा, फिर you have the other monomer, which is a diol. ठीक है, this other monomer has OH groups on both sides. ठीक है, so it's got an OH group and it's got another
सर
OH group.
तो स्क्वायर शेप क्या रिप्रेजेंट कर रहा है?
क्या? In anything, कोई भी बीच में चीज होगी ना, that's it represents that. ठीक है, कार्बन चेन कुछ भी हो सकता है, बट दोनों एंड्स पे ना there's a carboxylic acid group and on the other side there is a diol. ठीक है, और वही होगा, what's going to happen is कि they're going to endlessly repeat, and eventually what will happen is कि there's going to be a condensation reaction that's going to take place कि the OH and H are going to get removed. So the OH and H are going to get removed. So the OH goes and the H goes as well. ठीक है, फिर वहां से दोबारा से alcohol loses the H, the carboxylic acid loses its OH lost, H is lost, H is lost. ठीक है, ends के ऊपर it's endlessly continuing. So that is what's going to happen. और फिर they're going to all join up. बीच में water बन जाएगा, and all these molecules or single monomers, they will eventually get added up. ठीक है, so ये मैं remove कर रहा हूँ. OH is gone, OH and H is gone, H is gone, OH is gone, OH is gone, H is gone, फिर यहाँ से, and they will all start linking up with each other. ये जो positive carbon है, that's going to get attracted to the lone pairs of oxygen and it will bond with it. This one will, the positive carbon will go in and get attached to the oxygen. ठीक है, this one will get attached over here or leave a continuation bond at the end, which shows के दूसरे end पे भी, which shows that the molecule is still continuing. ठीक है, that's, and every time there's going to be a water molecule that's going to be produced. ठीक है, a water molecule gets produced, another water molecule also gets produced, and so on. So that's why this is known as condensation, polymerization. And every time what you get is you get an ester link. That's why it's called a polyester. ठीक है, तो हर जगह an ester link is going to get produced. So this would be known as an ester linkage. As a secondly, this so that's polyester. You can also form a polyester with an acyl chloride as well. Okay, the only difference this is the monomers are dicarboxylic acid. And the other monomer is a diol. I said then you can also form a polyester using exactly same reaction using an acyl chloride. Okay, that can also result in the formation of. So this one will have. I mean, the only difference is that instead of OH, it will be Cl. यहाँ पे भी instead of these OH groups, there's going to be a Cl, and pretty much the Cl and H are going to get removed in this case. ठीक है, or basically what's happening is that this carbon had a strong positive charge, and this oxygen had lone pairs. So basically, what's happening is it's not an acid, a dicarboxylic acid. So basically, what's happening is the lone pair over here is getting attracted to the carbon that's positive. अच्छा मैंने ऊपर वाले के साथ सॉरी ड्रॉ कर लिया. ठीक है, तो so basically what's happening is an acyl chloride reacts with a diacyl chloride reacts with an alcohol. ठीक है, तो it's going to form an ester link, and the same thing with dicarboxylic acid. ठीक है, so the only difference is कि एक जगह पे diacyl chloride use हो रहा है, the other one you're using a dicarboxylic acid. That's the only difference, but both of the cases will result in the formation of a polyester. ठीक है, ये clear है बात?
Yes, sir.
और इसकी ना examples कि you need some examples again, just O-level stuff. You've got terylene, which is clothing and fabrics, etc. Okay, so one of the examples is terylene. The fabric, clothing. Then you have natural. You've got fats. Fats are very similar to natural polyesters are fats. I mean, they're not very big molecules, but fats kind of resemble natural polyester. Okay, this is what a fat molecule would look like. उसके लिए poly word use करना that would not be suitable, but the fat molecules have ester linkages. ठीक है, ये plenty of examples. ये वाला example is इसका. So you can see a bunch of you can see a fat molecule, and the linkages between them is an ester link. Okay, there's an ester link that's connecting them all together. So not exactly the same format, but at least you have an ester linkage. Okay, so they resemble a polyester. Natural polymers में ये आ जाता है. I said then you have another one which is polyamide. Okay, which is also kind of वो second type है, ठीक है, of a condensation polymer, which is also kind of very similar to second, you know, that's so I'll just copy the same one and make the changes on it. Okay, the only difference is it's not going to have an amide, not going to have an ester link, it's going to have an amide link. And the monomer in this case is going to be, instead of the carboxylic acid is still there. Actually, they don't actually use the carboxylic acid. What they use is an acyl chloride, okay? So an acyl chloride is used, a diacyl chloride. तो उसमें ना ये तो OH नहीं होगा. This one will not be there, ठीक है? Let me just correct. You're not using diols. No OH. Achha, so what you're using in as diacyl chloride is Cl. This one is going to be NH2. So there's going to be an N with two H's. So it's going to be a diamine. Okay, again an acyl chloride. It's an NH2. And something similar will happen, which is kind of very similar to what, I mean, actually it's exactly the same as polymers. Except you didn't study acyl chlorides. So polyamides will be made from diacyl chlorides, okay? And this one will be a diamine. Okay? This one is going to be a diamine. Something similar happens, which is okay, why do they react? Because the N has lone pairs and the carbon has a very strong positive charge. So the lone pair on N is going to get attracted to the carbon, and each percent H and Cl are going to get removed. So H and Cl are removed, Cl is removed, H and Cl are removed. तो वो N से ठीक है. The only difference is now your linkage is not going to be an ester linkage. It's going to look like this. So it's going to look like this, that there's going to be an N with an H, and you're going to have a C with a double bond O. You get this one also, N with an H will go and directly bond with a C with a double bond O. That's an amide link. Okay, यहाँ पे there's going to be a C double bond O on the left side. So this one will be C double bond O and N with an H, or NH2 होगा actually. Right side पे क्या, there's just N with an H. Yes, I've just connected the missing thing that's now known as an amide link. ठीक है, C double bond O with NH. That's amide linkage. So that one is amide linkage. And you're going to have repeat units of sorry, इस case में the side product is going to be, the byproduct is going to be HCl, not H2O. ठीक है, every
सर
time
HCl होगा.
हाँ HCl होगा. ठीक है, every time HOCl remove हो रहा है, so HCl is going to be your byproduct. ठीक है, तो polyamides, and this one is polyesters, ठीक है. Proteins हमने पहले कर लिया था. I told you that proteins are formed. They're also a type of condensation polymer and the type of a polyamide, ठीक है. तो उसके अंदर you had a amino acid reacting with another amino acid, so it was also a reaction between a carboxylic acid and an amine. So this one is also kind of very similar. Polyamides, it's a diamine reacting with a diacylfluoride. इसके examples क्या हैं जो ओलम्स में पढ़े थे? One of them was well, natural के अंदर you get proteins, right? But you've got Kevlar, you've got nylon. So these are, or natural के अंदर ना you've got proteins. ठीक है. So this one बाकी बाकी एक they can be broken down back again by dilute acid, dilute alkali. वो ऐसे biodegradable polymers we can अच्छा acidic and alkaline hydrolysis, ठीक है. ये डिस्कस कर लेते हैं, ठीक है. Or organic synthesis, ठीक है. बाकी then you have analytical. Just 1 second, let me just go through. Between amino acids we did that, ठीक है. बाकी तो it's just drawing, ठीक है, practicing this. अच्छा उसके अंदर उसने कहा कि यहाँ पे you can also have a dicarboxylic acid. अच्छा, why would that be a bad choice, by the way, to make a polyamide? Okay, if you use a carboxylic acid, remember amines are basic. So you might end up with an acid-base reaction. Okay, wo jo lone pair hai na, that will accept the H+1 and the carboxylic acid would lose the H+1. So which is why usually for polyamide formation, you don't prefer carboxylic acid because amines are basic. So instead of a condensation reaction, you end up with an acid-based reaction. तो लेकिन उसका
सर
हाँ
सर आपने क्या किया कि न्यूट्रलाइजेशन होगी?
हाँ, क्योंकि अगर कार्बोक्सिलिक एसिड यूज करोगे तो अपना H+1 लूज करेगा. amine जो है will accept an H+1, so that's an acid based reaction instead of an elimination or condensation reaction. Is that clear?
यस सर.
और यहाँ पे ना this is again there's addition elimination happening technically. Like the monomers are getting added up, but at the same time there's a small molecule that's getting eliminated as well. ठीक है. तो condensation reactions are technically, these are condensation polymerization are technically addition elimination reactions. अच्छा, अब आ जाते हैं उसके प्रॉपर्टीज के ऊपर के. अच्छा, there was another one which you studied in AS, ठीक है, that was addition polymerization. I won't go into that much detail about that. Okay, what happens in addition polymers is your monomer is an alkene. ठीक है, this is, you've already done this one in AS. So I'll just do one example. Let's say I have a propene molecule. The propene molecule, this is how it's going to look like. Okay, that's a propene molecule. Now, what will happen in this case is in this specific case, what's going to happen is the double bonds will all get added to each other. ठीक है, but you would have to draw this molecule in a slightly different way कि उसके ना double bond के right side and left side they must be open. So there's an H on the top. So any atom that's on the right side, just draw it in a bent way downwards. Or either mean anything that's on the left side, just draw it or slightly bend it downwards. Okay, so the CH3 will be bent. So the first thing is what you do is when you make an addition polymer is you sort of rearrange the molecule. You don't break any bonds. You just draw it differently. That's it. ठीक है, मैंने कुछ भी नहीं किया. That's I just sort of bent it downwards. H on the right side. I just drew the H on the bottom side. And lots of these tiny monomers will join up. And under high pressures, high temperatures, they'll all form. So they'll all form polymer. Okay, this is addition. This one is just addition happening. Okay, there is no small molecule that's getting eliminated, just plain addition. All the double bonds are going to break. They'll turn into single bonds. And carbon would need to has to make another bond in this case. So what carbon will do is it's going to connect with the other carbons. All of them are short of one bond, so they'll all start to link up, and that's polypropene now. Okay, so this one is polypropene. Now the thing is, let's just analyze. First thing, let's write down the repeat unit. Like, how do you draw the repeat unit of a polymer? Okay, you just figure out what structure is repeating over and over again. So यहाँ पे what's the repeat unit of this molecule? It's आवाज आ रही है सर को? अच्छा, that's your repeat unit. That's repeating over and over again. So you just write N. You can make sure you draw these continuation bonds. So this is the thing that's repeating over and over again. So that's known as the repeat unit. So you just copy that part which continuously repeats. ऊपर वाले case में क्या है कि if I look over here, what's the structure that's repeating over and over again? That's like if I start over here, so I think after this point, I mean, this is the point where it starts to repeat again. But इसको गौर से देख लो कि that's the and when you're trying to figure out the repeat unit, you can start at any point, okay, as long as you end up so ये NH दोबारा कहाँ से repeat हो रहा है? It starts repeating at this point, right? Or if I had started with serial bond O, then the structure would have repeated. But अगर मैं कोई और repeat unit इसका ढूंढता ना, तो that would have been this. I mean, I would start at this point. When does the structure starts to repeat again? It's this point. ठीक है. उसके बाद से ना you again get serial bond O and NH. So make sure you're able to figure out what the repeat unit is. It doesn't matter what the starting point is. I could have started at this point. So when does the structure repeat again? It repeats at this point. But anyways, that's my repeat unit. You clear?
Yes, sir.
So the next इसका क्या था repeat unit? That's I guess if I start at this point, when does it repeat? I think it repeats over here. नहीं, ये वाला भी बीच में डाल दो. हाँ, now it repeats. ठीक है. हाँ. वो सीरियल बॉन्ड वो दोबारा आ जाता है, ठीक है. So this is up till this point. So that's going to be my, ये हटा दो. अच्छा, so that's going to be my repeat unit. ठीक है, this thing repeats. ये जो exact part है ना serial bond ONO, it comes over here. So up till this point, and after that it starts to repeat. Also remember that अच्छा चलो ये तो N हो गया. Also remember that you could start at any point. You could have started above. यहाँ से भी start कर सकते थे the box. मतलब if I had started at this point, then serial bond O फिर से ये box तक, ठीक है, that would be repeating again after this point. So एक तो ये हो गया. अच्छा, then you have properties, ठीक है. The properties of specifically addition polymerization and condensation polymerization, ठीक है. We'll just compare the properties. Addition जो है ना वो usually box कुछ भी हो सकता है. I mean, if there's a box, ठीक है, that could be, that just means it could be anything, ठीक है. यानी if I have CH2 and there's a carboxylic acid on both sides, so that's the box in the middle. The box could be anything. We don't care about the middle part, ठीक है. We just care about the ends. तो ये थोड़ा सा याद रखना कि box जो है ना, that simply could mean anything, ठीक है. And आपको boxes most likely वो नहीं देंगे. They're not going to give you boxes. They're going to give you something over here, ठीक है. We'll just do questions after this. अच्छा, then the next part is कि, अच्छा, next part is कि you've got हाँ, comparison. Addition polymers versus condensation polymers. अच्छा, इसमें ये कि now addition polymers are inert. The first thing is they are inert and non-biodegradable. They don't decompose easily. ठीक है. For example, ये PVC के plastic pipes वगैरह, ठीक है. Polyethylene, most of the plastic bags are polyethylene. You've got another one which is और कौन सा है, polypropylene, ठीक है. Most of your bottles they're made out of polypropylene. So it's like you've got lots of, and they're all non-biodegradable, which means they don't break down that easily. And the reason being that the linkage is basically a non-polar carbon chain. Whenever you look at an addition polymer, that's a non-polar carbon chain. So it's very stable and it's very unreactive. And also happens to be very, very, as it also happens to be very, very unreactive. So on the other hand, you've got condensation polymers. Condensation polymers, you either have, you've got very polar linkages. So you've got very polar linkages, and like if you have an ester link or you have an amide link, it's the carbon has a very strong positive charge. The oxygen has a very strong negative charge. So these linkages happen to be very, very, they happen to be very, very reactive. Amide be very reactive होता है. Amide तो बल्कि hydrogen bonding भी करता है. So it's got strong attraction as well. So same case with amide, the carbon is very strongly positive, the oxygen is negative, N has lone pairs also negative. So they're very polar linkages, which makes them very reactive. They get very reactive and they get easily hydrolyzed. Okay, because they're going to attract a lot of things. Okay, so very reactive and hydrolyze easily. तो आपने खाली क्या करना है कि what you just have to do is कि heat या फिर boil with strong acid or strong alkali. Dilute acid, sorry. So dilute acid or dilute acid. तो और ये चीज याद रखनी है कि make sure you remember this. ठीक है, ये मैंने हाईलाइट भी कर दिया. ठीक है, always heat or boil uh, with the strong alkali and they're going to get broken down. ठीक है. अच्छा बाकी ट्राइपेप्टाइड्स इलेक्ट्रोफोरेसिस वगैरह वो सारा तो हम बाद में करेंगे एनालिटिकल के अंदर. अल्कलाइन हाइड्रोलिसिस इसके बारे में कुछ नहीं है, जैसे एक्शन ऑफ लाइट के सम ऑफ देम माइट गेट ब्रोकन डाउन. हाँ, finally there's another thing which is known as organic synthesis. चलिए इस लो आवाज आ रही है.
अच्छा
अच्छा, organic synthesis का बस आइडिया ये कि all these reactions that we've done, like I mean, you know, कि if somebody is asking you to predict properties, reactions, OH group लगा हुआ है, carboxylic लगा हुआ है, so you can pretty much do most of that stuff. If they want you to, a synthetic route is this thing कि how do you make a certain compound. ठीक है, for example, I mean, जितनी भी chemistry पढ़ी ना organic, that is about synthetic routes. कि जैसे ये था बल्कि उससे पहले जैसे azodiaz में पढ़ा था, these are all synthetic routes के you take a benzene and you add NO2 to it, then you turn it into NH2, then you make it into a diazonamine. So these are all synthetic routes. So we've actually covered all of that. ठीक है. अब अब इसमें ना एक जो चीज है ना, अब वो पता नहीं पिछले सिलेबस में थी लेकिन इधर क्लियरली मेंशन नहीं है, but I'll teach you anyways. That's a very small thing, and that's this thing कि और synthetic routes के अंदर ना, I'll explain to you very quickly कि sometimes there's a problem with सिलेबस में वैसे मेंशन नहीं किया हुआ. एक सेकंड. अच्छा स्टीरियो का वर्ड ना वो एएस वाले पार्ट में पढ़ा हुआ है अभी तक. So I'm guessing that's not in no longer in the syllabus. ठीक है. देखिए उसके ऊपर थोड़ी सी डिस्कशन है. I'll probably do it. Otherwise, we're actually done with organic chemistry. ठीक है. We'll do past paper questions now. ठीक है. We've covered everything from electrophilic substitution to carboxylic acid comparison basis. Acid comparison, basis comparison, hydrolysis of chlorine related compounds, and और उसके बाद जितने भी बाकी oxidation reduction reactions, we did all of them. So we'll just तो नेक्स्ट क्लास में विल डू अ लॉट ऑफ पास्ट पेपर क्वेश्चंस. ठीक है. एंड
सर
हाँ,
सर आपने वो इलेक्ट्रोफोरेसिस का आपने मेंशन किया है उसमें.
वो एनालिटिकल के अंदर पढ़ेंगे. उसका ऑर्गेनिक से कोई ताल्लुक नहीं है वैसे. ठीक है. वो है लिखा हुआ तो सिलेबस में ऑर्गेनिक में, लेकिन उसका मतलब कोई ऑर्गेनिक के साथ कोई सेंस नहीं उसकी. इट्स एन एनालिटिकल टेक्निक. ठीक है. तो वो उसके अंदर पढ़ लेंगे.
अच्छा. एक लास्ट क्वेश्चन है सर, थोड़ा सा लाइक आउट ऑफ टॉपिक है, लेकिन वो मैं पूछ रहा था कि जो हमारे जो मार्क्स की है ना सर, वो ट्रांजिशन एलिमेंट्स के लिए जो था
हाँ.
सर, उसके अंदर पहले वो 4 लिखते थे ना वो कॉपर के लिए, जब हम लोग 2 सोडियम हाइड्रोक्साइड ऐड करते थे. सर अभी वहां पे आ रहा है कि लाइक सिर्फ वो H2O4 को लाइक वो कंसिडर नहीं करेगा, सिर्फ OH2 को कंसिडर करेंगे
हाँ
मार्क्स स्कीम में.
तो मैंने वही बताया था तुम लोगों को.
ओके.
मैंने बताया था कि ये है ना किधर है. अम, वो इधर मैं दिखा भी देता हूँ. बस ये क्लास खत्म होगी. ये कल से फिर पास पेपर करते हैं ऑर्गेनिक के. ये मैं दिखा देता हूँ कि ट्रांजिशन कहाँ पे है. हमने OH2 ही लिखा था ना. वो मैंने एक्सप्लेन किया था कि वो जहाँ पे भी है उसमें बताया था कि वो न्यूट्रल हो जाता है फिर वो वाटर को भी हटा देता है. ठीक है. क्लियर है.
हाँ सर, वो फिर H2 अलग से लिखना होता है फिर.
हाँ. हाँ वही लिखा हुआ है ना हमने.
और सर वो कोबाल्ट के कलर सर आप प्लीज शो कर सकते हैं? सिर्फ वो कंफर्म कराना था सर प्लीज.
अच्छा ये मैं खोल देता हूँ. मैं वो देख रहा हूँ कि कौन सा वाला. ये थी मेरे ख्याल से. तो ये रख लो ना. ये है ना. इसलिए मैंने वो भी भेजी थी. PDF भी भेजी थी. ये कलर्स थे ना. ये वाला बोर्ड.
यस.
हाँ. ये वाला बोर्ड नहीं था. अच्छा ये कोबाल्ट के कलर्स हैं. ठीक है. सेम एग्जैक्ट लाइगेंड एक्सचेंज विद कोबाल्ट 2 और ये उसके कलर्स हैं. ठीक है.
ओके था जी, थैंक यू सर.
चल. ओके. अच्छा 4 बोर्ड्स हैं. आई एम शेयरिंग ऑल ऑफ देम. ठीक है.